Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management.
KubeCon, Cloud Native Con conferences gather adopters and technologists to further the education and advancement of cloud-native computing. The vendor-neutral events feature domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more.
Today on the New Stack Makers, I have one of my favorite people in this world, Janakiram MSV, who wrote our second edition of the Kubernetes ebook that we first ran in circa 2017, 2018. And now Johnny is here to talk with us about platform operations, which is becoming an increasing topic of interest. And I wanted to start off, first of all, Janakiram, thank you very much for joining us. Janakiram MSV of Janakiram and Associates. Johnny, so great to have you here.
My pleasure, Alex. It's always great catching up with you.
Yeah, we have a lot of fun in these conversations. And one of my favorite conversations came last year at the KubeCon in San Diego. And a lot has changed since then, as it always does between these events. And one of the things that you talk about right now is this parallel universe that we're seeing emerge. We have the universe of, I think, which you could almost describe as monolithic architectures, monolithic technologies, and then this new world of this new control plane and this new data plane. And so it's almost like this parallel universe that we're seeing emerge. I would like to talk about that. I'd like to talk about the developer experience that we're seeing, GitOps as a real standard practice we're starting to see emerge, and then this idea of cluster sprawl and the ideas of how that relates to multi-cloud. So let's talk about this parallel universe. How do you see this parallel universe emerging?
Absolutely. It's one of my favorite topics. So I want to step back a little. What was prior to cloud native? Well, cloud native is a buzzword. It's a jargon. A lot of us refer to that very often. But what do you call the world before cloud native took over? So I actually call it as cloud ready. So cloud ready was the era where physical machines got converted to virtual machines and then eventually made their way to the public cloud. They were not built for the cloud, but they were fit for the cloud, and they could move from a bare metal to a virtual machine in the data center to the public cloud. And then that phenomenon led to the creation of a huge ecosystem. And the pioneer of that ecosystem was obviously VMware. It created the hypervisor, the most popular hypervisor. And just because the hypervisor became the new layer, almost the new operating system, there came in the software-defined storage, software-defined networking, software-defined compute, and then that led to hyper-converged infrastructure. And there was a whole new world of virtualized infrastructure, be it storage, be it networking, be it compute. And that universe grew pretty large. There was an explosion in the cloud-ready world almost a decade ago. Now, fast forward that to 2020. Today, we have cloud native. And interestingly, the trend is like almost a repeat of what actually happened during the cloud-ready era. So there we had hypervisor as the key enabler, and here we have the container engine plus the container orchestrator. So there are a lot of commercial distributions. There are upstream Kubernetes, open source. So that is one element. And then just like we had software-defined storage network in the cloud-ready era, we have container-native storage, container-native networking, and container-native observability, which is actually monitoring, but now augmented and contextualized to become observability. And then we have cloud-native security, which didn't exist just 5 years ago. And today, image scanning and integration with OIDC and admission controls and security within the context of Kubernetes and cloud native ecosystem is huge. So interestingly, everything that happened with the VM and the virtualization world is now happening with Kubernetes and the containerization world. So literally, you can draw a column and kind of compare each technology in the cloud ready era with cloud native era, and we have a parallel. And in fact, that's the theme that I have taken in the chapter 2 of the ebook on the Kubernetes ecosystem. All the way from the operating systems. Now, the operating system has gone through a significant transformation because of Kubernetes. The role of an operating system is very different from what it was just 5 years ago. Today, we have Fedora CoreOS, which is actually a very, very minimalistic container optimized operating system. Then we have Flatcar. And of course, CoreOS got subsumed into Fedora CoreOS, but it was another popular choice. Then we have commercial vendors building operating systems exclusively for Kubernetes and containers like Talos. So starting from the bottommost layer of the stack, which is the operating system, and all the way to the developer experience, which is the topmost layer. And by the way, all the blocks between the developer experience and the operating system are well-defined, well-articulated, and explained in the ebook. Sorry for the plug, but if you're further interested in mapping the cloud-ready world with the cloud-native world and how they stack up, you should actually download the book and read the second chapter that basically layers the entire cloud-native stack and explains how it maps to the new ecosystem that is actually exploding. It is growing exponentially.
So when you think about the developer experience, then what does change? For instance, I think of things that change in processes and workflows, such as we don't hear as much discussed about continuous integration. We hear more about continuous delivery, for instance.
Right. So honestly, we discussed this at KubeCon San Diego, and interestingly, that theme and that gap still exists in the ecosystem. If the Kubernetes and cloud native ecosystem has to focus on something, and if there is still some white space left for commercialization and monetization, I think it's developer experience. Because as we discussed in the past, Alex, it's very hard to define what is Kubernetes, right? Is it a developer platform? Is it an infrastructure services layer? Is it a DevOps platform? Is it just an orchestration manager? It means different things to different people. And now with operators and CRDs, the definition is going way beyond container orchestration. So it has become very confusing for the personas. A developer has to know a lot about what's going inside Kubernetes. The administrator and the operator has to know a lot about services and microservices now if they're implementing service mesh. So the line between developer experience and platform experience and operational experience is getting completely blurred. Everyone has to know everything about Kubernetes. But I want to call out some examples of how this is being addressed. First thing, we should give it to Red Hat. Red Hat has done a phenomenal job of platformizing Kubernetes right from day one. The day they realized that OpenShift got to be a containerized platform and they moved away from their proprietary architecture to Kubernetes, they squarely focused on delivering developer experience. And that's the reason why OpenShift really stands out in the enterprise. But beyond OpenShift, we don't have any such PaaS that's actually built on top of Kubernetes, that is making it easy for the developer. So what exactly does a developer want from a platform, right? It's very simple. Heroku, IngenueYard, App Engine, Azure, Beanstalk from AWS. What is common across all these PaaS offerings? It's very simple. You bring us code and we'll give you a URL. That is the promise of PaaS, right? And this was democratized by very early implementations of platform as a service offering, Cloud Foundry, Heroku, IngenueYard. Today, if I'm a developer, do I get the same convenience of bringing my source code and going away with a URL? No. I need to know so many moving parts in the Kubernetes ecosystem. I need to understand ingress. I need to understand load balancers. I need to understand service discovery. a lot many building blocks are exposed to the developer. So that is where the challenge is. So there is tremendous opportunity still that exists in the ecosystem, which is building the developer experience, which will enable a developer to bring his source code and go away with a URL instead of really building a Docker image, pushing that to a registry, turning that into a pod, exposing that as a service, and then stitching all of them together as an ingress. Now, this has to go away. This has to be simplified for the developer. The developer persona doesn't appreciate the Kubernetes workflow because they're not used to it. Now, luckily, there is some work that is being done in this space. And again, one of my favorite projects is the open application model that has gained a lot of attention and momentum since we last spoke in San Diego. So open application model is a joint collaboration. It's an effort coming from Alibaba and Microsoft. And it has gained a lot of attention. And particularly some of the open source projects like Crossplane, which is building a cloud native layer for traditional resources. Even that is embracing OAM, which is open application model. And open application model hides the nuts and bolts of Kubernetes and exposes what is required for the developer. And that is the a step in the right direction. And eventually, when OAM is accepted by the larger ecosystem, particularly the platform vendors, it has a potential to simplify it for developer. And then one of my other favorite projects, instantly from Microsoft, is Dapper, Distributed Application Runtime. It is not so much to do with Kubernetes, but it does simplify a lot of mundane tasks that the developer has to implement. So to call out, we still don't have an OpenShift in the Kubernetes world. It is still an OpenShift, which is promising full-blown, full-fledged pass for developers. Then we have a couple of projects that are moving in the right direction, particularly open application model and distributed application runtime. We need to simplify this. So that is where we are in terms of the developer experience and what is lacking in the cloud native ecosystem.
We are seeing some simplification. I believe that when you look at how GitOps has emerged, that definitely is an effort to simplify how you actually manage the workflows that you're and approaches that you're taking to building on Kubernetes. And so that provides a Git-based method for doing version control and reaching that desired state. Would you agree with that?
Absolutely. I'm a big fan of GitOps. I think it's again, it is going to be the de facto for Kubernetes-based deployments and managing desired state configuration. But unfortunately, even if I'm a developer familiar with the Git taxonomy, I still need to deal with YAML files. I still need to deal with Helm charts because GitOps doesn't abstract away the way Kubernetes is exposed to the developer. It is just a new mechanism, a deployment mechanism, which will simplify the overall workflow, but doesn't take away the complexity involved in defining YAML files, Helm charts, and the rest of the. So basically, for the audience here, for the viewers, for me, GitOps is like a for each on every cluster and doing a kubectl apply. So technically, you're not really doing anything different. Instead of doing kubectl apply on a bunch of clusters in a for each loop, you are putting all your artifacts in one GitHub or a Git repo, and you're pointing all the clusters to that. And then an agent that runs inside the cluster will actually do a pull and applies the spec internally by calling the API server. Of course, the advantage is every time there's a drift between the cluster state, the workload state, and what is defined as a single source of truth in the Git repo, this mechanism will bridge the gap. It will always make sure that the cluster state is reflecting what is defined in the single source of truth, which is the Git repo. But it doesn't really take away the complexity in terms of dealing with the primitives of Kubernetes.
Right.
So that's where it is.
So you have this problem. Then you have developers having to do a lot of configurations. It's something that we've talked about before. You have these multiple personas that may cut across one or multiple individuals. And so when we talked to, for instance, Box the other day, Bob Kunal over there, who's the director of engineering, Kunal is saying that one of the problems that they really face is that they're trying to serve like multiple camps. So they're serving the developer who just doesn't really care about the infrastructure and just wants to code. And then the more power user who does care about the infrastructure. So GitOps can help be, an approach that you take to building, but, this seems to be a problem is like, serving these multiple constituencies to create that experience that actually is manageable and helps kind of scale out a Kubernetes architecture across an organization.
Absolutely. Going back to my point of Kubernetes creating a parallel universe, as it actually creates the new software or rather container-defined, container-native storage, container-native networking, observability, DevSecOps, and so on, it also demands new skills. Today, we don't have specialized job functions in an organization. But if you look at the way the infrastructure is run in enterprise, there are dedicated teams for storage, for network, for security, and for the overall platform availability. And today, the job description that is published outside, when an organization is hiring Kubernetes professionals, they're not really going with these dedicated job functions or roles or the very focused persona, right? Today, if I'm a Kubernetes administrator, I'm expected to know everything, all the way from, the kubelet that is running inside every node, all the way up to the stack. I'm expected to know everything. And that is very unrealistic. We need to have well-defined personas and well-defined roles. For example, you'll have cloud native database administrators, who master the art of managing and maintaining cloud native databases, because backup recovery, business continuity, disaster recovery, snapshots, all of that is very different in the cloud native world. It deserves a dedicated function. And similarly, container native networking, right? Cloud native networking and CNI based networks. Not everyone can handle that. Project Calico, which is offered as a commercial offering from Tigera, is pretty complex. You cannot expect a generalist SRE to know about Calico and apply network policies. Same thing with storage. So now bringing this into the context of GitOps, does it make it easy? Does it help the overall organization? Yes, it does, definitely. But the spec that is applying a pod security policy, which is a part of DevSecOps, or the network routing policies and the security policy related to network is very network specific. Someone has to define it really well. Similarly, storage classes and storage policies, the quotas, those need to be defined by someone who understands that. So GitOps is the vehicle, but the specs that are put inside the GitOps repo still need to be authored by experts who are focused on these layers of the cloud native stack. And they are the part of the new ecosystem and the new universe.
That becomes a much deeper issue, doesn't it? Because it gets to the kind of the root of how people are trained, really, and how they're and certified and helped in preparing for these roles. Because, as you state, networking, for instance, Calico is a whole different type of networking approach, as is the approaches that you see in container storage, and what you're also seeing in in other aspects of the world is so that parallel universe actually has a real problem, because in that parallel universe you have lots to manage, but you don't necessarily have the expertise to do it.
Exactly. So my suggestion is this: for aspiring Kubernetes professionals, I don't call them administrators or developers, because that's a very confusing function. But if you are trying to build career in Kubernetes, learn the basics, understand the big picture, but it is time for you to master one of the layers of the cloud native stack. So you cannot be a master of everything. So what will really matter 2 years from now is how well you know the Kubernetes. It is not how well you know the Kubernetes architecture. It is, are you an expert in networking in Kubernetes context? Are you an expert in storage operations? Are you an expert in observability? How do you manage the logs, metrics, events, and alerts generated by your cluster and your workloads? And how do you manage the overall SLO, SLA, and other critical things that matter to the business, which is an SRE role? So don't take a generalist approach. Instead, understand the big picture, but laser focus on one of the layers of the cloud native stack and become a master at it. And that is the direction that the industry is taking. And one such indicators is from the CNCF certification. So earlier they had CKA, which is Certified Kubernetes Administrator, and then CCAD, Certified Kubernetes App Developer. And now they're actually launching a Certified Kubernetes Security Administrator. And that is an indication on the specialization that is coming up. So, just like 10 years ago, I could claim to be a cloud administrator, and I would manage object storage to virtual machines to block storage to databases. But today, cloud is like the overall IT industry. You cannot claim to be a cloud professional. You have to be very, very focused on, okay, I'm a cloud specialist, but focused on databases, focused on storage, focused on compute, focused on networking. And then you have something very, very critical to handle and ability to demonstrate value to your organization or to your customer. That's exactly how we should approach the cloud native ecosystem. We cannot be a generalist of all things Kubernetes and claim to be an expert of the entire stack. That is going to change very soon. Very soon, as in next 6 months or so.
That role of the certified Kubernetes administrator, what are the skill sets you're seeing for the people who are filling in those roles?
So currently, it is a generalist role because organizations haven't matured, the Kubernetes users haven't matured. So today, the expectation is I'm going to hire a CKA, the Certified Kubernetes Administrator, and he will run my cluster. He's going to own everything, and he will get everything up and running. But that's a very unrealistic expectation, because it is extremely hard for a persona to handle the entire stack. Unfortunately, that's where we are. The market expectations, the technical readiness, and the way Kubernetes is positioned in the market, it is like a black box platform, a black box technology that can magically run everything, and that can be very easily managed by a bunch of administrators. But that's not the case. Running Kubernetes in production requires specialists, and their expertise for on each of the layers is very, very critical for the success.
Right. So it could be storage, could be networking. So let's move into discussing, perhaps we can segue into that kind of deep need for skill sets when we see the proliferation of clusters, as you're saying, and this cluster sprawl issue and this issue of multi-cloud. That very much speaks to the need to be able to have people who can manage these types of these new issues.
Absolutely. So what has changed since last KubeCon is the meta control plane, right? So today, it is extremely easy to push a button and launch a Kubernetes cluster. Whether it is GKE, EKS, or AKS, they made it so simple that, in fact, it's much more easier for me to launch a Kubernetes cluster than spinning up a VM and installing software on it. So a lot of developers have started to create a cluster, instead of creating a namespace and targeting that in an existing cluster, because they have to do quite a bit of plumbing. They have to create a cluster role. They have to do a cluster role binding. Then they have to create roles within specific namespace. And then they have to carefully confine their application to that namespace and provide guardrails and so on. Instead, the users are finding it very easy to spin up a cluster, all the way from Minikube running on their laptop to K3s running on a Raspberry Pi, or to a managed Kubernetes cluster running in GCP or AWS. So this is resulting in a huge proliferation of Kubernetes clusters, and it is a cluster sprawl. There is absolutely no control. There is no inventory of these clusters that are lurking everywhere and running everywhere. And moreover, for enterprise, if they have policies that need to be enforced and imposed on every cluster, they are not able to do it. So these clusters can run anywhere from a developer's laptop to the enterprise data center to the public cloud, and in fact, multiple clouds. So there are clusters all over. So the challenge of managing Kubernetes worker nodes at scale is already tackled. Kubernetes has proven that it can effectively handle thousands of nodes, and it can handle the orchestration very efficiently. But now the new challenge is thousands of clusters. It's not thousands of nodes. That is done. That is like, we have mastered the art of orchestrating and managing worker nodes and workloads. But now the challenge is, how do I manage thousands of clusters that are running everywhere? Well, the answer is create a meta control plane, right? If Kubernetes control plane is handling worker nodes, create a meta control plane that will sit on top of these clusters and can tackle the overall cluster management, irrespective of where they're actually running. And that is the next big thing. So, as I mentioned in the other panel, there are two approaches to it. One is, this is becoming a monetization option for cloud providers, right? And some of the early indicators are Anthos by Google, Azure Arc, VMware Stanzo, Red Hat Advanced Cluster Manager, and then Rancher 2.0. What is common across all this is they can effectively manage Kubernetes clusters irrespective of where they are running. And they'll give you a single pane of glass. It's a very cliche term, but the single pane of glass that gives you control and visibility into pretty much every cluster. In fact, Rancher is one of the pioneers. And I sincerely hope after SUSE's acquisition, it continues to innovate and it continues to be the meta control plane. But that is the direction that the commercial vendors are taking. And on the open source and the cloud native front, we have Cluster API, which is going to effectively deal with the same. So instead of creating clusters outside of the Kubernetes context, as in you create a cluster using KubeSpray or RKE or KubeADM or COPS, which are all the tools to spin up a new Kubernetes cluster. You can actually use an existing Kubernetes cluster to spin up a new Kubernetes cluster, a child cluster. And that is going to put you in a better form, because you have visibility and you can make sure that every child cluster spawning out of your master cluster or the parent cluster can actually ensure that these child clusters are running the right set of storage, network, and security policies. So that is the direction that the Kubernetes ecosystem is taking. And the commercial vendors are now looking at this as a monetization technique. And because Kubernetes is the same everywhere, they want to differentiate by offering a better mechanism of managing the meta control plane. And that is what Azure Arc, Anthos, and Tanzu are all about.
That speaks then to this parallel universe, doesn't it? And we saw historically the need to control virtualized machines when they were becoming predominant in IT infrastructure. Today, we're seeing the proliferation of container technologies and the clusters that they're hosted upon. And so you're saying that we need more controls over those clusters, which can be done through, it sounds like, through the container orchestration engine itself, and maybe even through these, mechanisms. I don't know if they're custom resource definitions or what, but there seems to be this new this is the new frontier, and the new frontier we talk about is really is what comes from necessity more so than innovation.
Exactly. So the fundamental difference between the virtualization world and containerized world is, virtualization, the hypervisors were very diverse and they were not interoperable. ESXi, KVM, Xen, Hyper-V, they never had any kind of interoperability. And the VM format used by each of these hypervisors was extremely different. Now, switch to Kubernetes. The beauty of Kubernetes is there is a level playing field. The lowest common denominator in this stack is the Kubernetes layer. And thanks to CNCF compliance and conformance, no one can deviate from that. So when you know that the lowest common denominator is exactly the same in a variety of environments, then you can build additional layers on top of it. Kubernetes is augmented by these meta control planes and cluster managers, which was not possible in the previous cloud ready or the virtualization era. So definitely a huge opportunity. And this is also required by customers, because if you look at the three attributes of this meta control plane, and I'm talking about Anthos, Azure Arc, and Tanzu, for example, there are three attributes. First thing, all of them will give you an option to attach a cluster to the control plane. So they'll give you a nice agent which will run in your cluster and calls home, which is the cloud-based control plane, and then establishes a connection between your external cluster and the meta control plane. That is the first attribute, an agent to bridge that. Second thing is all these meta control planes have a complementary GitOps engine. For example, Azure Arc is built on top of Flux, a CNCF project, very popular. And Google chose to build their proprietary GitOps engine called ConfigSys, and now it is actually called as the Anthos config management. Tanzu will follow this suit. So that is the second attribute, a GitOps-based engine to push common artifacts, policies, and deployments across all the participating clusters. The third thing is basically the managed services that will ride on top of the Kubernetes cluster. For example, if Microsoft is able to run its own Azure Arc cluster in GKE, then it can use that as a vehicle and it can run Azure SQL and some of the other managed services on the competitor's cloud, which is, it was not even possible, or it was impossible to think about it just a couple of years ago. And today, Microsoft makes it possible, right? Microsoft's promise is, you give me a Kubernetes cluster and I will give you a managed database with 99.9% uptime. Same route that Google has taken with Anthos, and they have shipped BigQuery Omni. Now imagine running BigQuery not in GCP, but on AWS, running on a Kubernetes cluster, which is managed by Google. So this mishmash and crisscross of Kubernetes clusters running all over opens up lot of opportunities, lot of new avenues for platform vendors as well as open source contributors and open source companies. And this is going to bring the entire infrastructure world on a level playing field. It doesn't matter where you run your Kubernetes cluster, but you can still run managed services like BigQuery and Azure Data Services. And who knows, in the next reinvent, AWS might launch something as a layer on top of Outposts and a multi-cloud Kubernetes layer on which they can run RDS and Dynamo. Quite possible. So that is the brave new world where cloud providers are able to bring their managed services to competitive cloud environments and still deliver on the SLA thanks to Kubernetes.
But we're going to really see the emergence of these new cloud services, aren't we, out of this too? Because if you're going to need ways to connect those different cloud services, and then you can do that through Kubernetes, then that does kind of realize it does provide a realization of these federated clusters, so to speak. Now, if we could just conclude here, because we only have a few more minutes, what would you say is, the trajectory for the platform operator, the platform operations role? It seems like it's going to become, more important.
Absolutely. So the takeaway is very simple. There are two call to actions. One, platform operations is going to be very niche and very specialized. It can't be a generalist kind of an approach to Kubernetes. This is going to be the big trend. Second thing is, Kubernetes is no more confined to a data center or a public cloud IaaS or a CAS environment. It is going to be all over. Kubernetes is becoming the cloud operating system. It is not just the data center operating system. It is a cloud operating system spanning pretty much every infrastructure services available today. And that opens up many opportunities. So to summarize and to repeat what I said, platform operations are going to be more niche, more specialized, and they will evolve into very, very fine-grained, very focused roles. Second thing is, Kubernetes will unleash itself from the data center or the public cloud provider and become the common fabric that is going to cut across every infrastructure layer, be it hybrid, be it public cloud, be it enterprise data center or edge devices. It is going to be one common fabric that is going to be cutting across all possible infrastructure layers. Two trends, watch out for the next 6 months, and this is what is going to really happen.
Great. All right. Well, thank you so much, Johnny, for taking the time to talk, and joined by my good friend and colleague in this business, Janakiram MSV, goes by Johnny to most. But thanks so much for your time, and we'll look forward to talking soon.
Thanks, Alex. I always enjoy these conversations. Thanks for having me.
You bet. Listen to more episodes of the New Stack Makers at thenewstack.io/podcast. Please rate and review us on iTunes, like us on YouTube, and follow us on SoundCloud. Thanks for listening, and see you next time.
KubeCon, Cloud Native Con conferences gather adopters and technologists to further the education and advancement of cloud native computing. The vendor-neutral events feature domain experts and key maintainers behind popular projects like Kubernetes, Prometheus, Envoy, Core DNS, Containerd, and more.